All right, any questions before we start today? All right, hearing none, what we're going to do today is we're going to start on section 3.5, so dividing polynomials. So probably this might be the easiest section so far this semester. So dividing polynomials is just like doing long division, really. And so to kind of show you, if you've forgotten what long division is, so what we're going to do is we're going to take 7, we're going to try to take 7 into 325. So that'll go in there before, that gives us 28. Now we subtract, so that's going to give us 4. We bring down our 5. Now 7 times 6 will give us 42. Where'd my 5 go? And so if I subtract again, that gives me 3. And so what we get is 46 and then 3 over 7. So this is our remainder. This is our divisor. Up here is our quotient. So I guess we can say the whole thing is quotient. And this is our dividend. Okay, and when I mean quotient, I mean the actual part that's there, not the remainder part. And so that's how you do long division, and that's how we're going to do division with polynomials as well. And one thing to note is, this comes into play when we look at the division algorithm, our dividend, which is the 325, is equal to the divisor, which is 7, times our actual quotient, which is just the 46, and then plus our remainder, and our remainder is just that part here. It's not the fraction part, it's just the 3. And so if we take 7 times 46 plus 3, we get our 325. And that's going to happen the same way as if we have polynomials here. So the key thing with polynomials is, with numbers, we have it just written, 325 or 502 or whatever it is. But with polynomials, we can have terms that are missing. And so when we want to divide, we have to make sure all terms are there in descending powers. So, if you start with a 4th degree polynomial, you have to have a x to the 4th, x to the 3rd, x squared, x, and then your number, and you have to have all those in there. And so if you don't have one of them, whatever variable is missing to that power, just use a coefficient of 0 times that to kind of as a placeholder. And then when you do your division, things will work out better. All right, so kind of like we had this piece here, we also have that for the division algorithm for polynomials. And with polynomials, because they're a polynomial and they're a function, what we're going to say is we're going to have f of x, our function of x, is equal to d of x, which is our divisor, times q of x, which is our quotient, plus our r of x, which is our remainder. And those, if we multiply them back out and add it together, we're going to get back our original polynomial function. Now, if our r of x after we do our division is equal to 0, then that means our d of x, which is our divisor, divides evenly into f of x, and so therefore the d of x and our q of x are both factors of f of x. And we're going to use that key to be able to actually start factoring polynomials as well. So that's part of what we're going to do today. Now there's 2 ways to do division. The first one is long division, and that's kind of just using all the x's, y's, or whatever we're using for the variable and dividing it out. So in that case, what we do is we put what we divide by, the divisor, out front. So in this case, x minus 5, and we divide that into what's the other part, whatever the dividend part is. And so in this case, it's 2x squared minus 9x minus 5. And then when we look at these, what we do is we look at the first term in our divisor and the first term in the dividend, or if we're at multiple stages, we always look at that first term. And so what we want to do is we want to go from x to get to 2x squared. So what do we have to multiply x by to get this? Well, we have to multiply it by a 2 for sure, and we also have to multiply it by x, so x times x is x squared. So if we take 2x now times the binomial x minus 5, that gives us 2x squared minus 10x. Now remember, we subtract, and since we have multiple pieces now, I'm going to put everything in parentheses and say subtract that whole thing. So now I have 2x squared minus 2x squared is 0x squared, so we're just going to leave that alone. We have a minus 9x plus 10x, so that's going to give us x. Now we bring down the next piece, which is x minus 5. Now this one divides evenly because x minus 5, if we multiply that by a plus 1, we get x minus 5. And then when we subtract that off, x minus x is 0, negative 5 plus 5 is 0. And so we get a remainder of 0. And so our answer to this is just 2x plus 1. And so that's what it is equal to. All right, so the next one is going to go along the same way, but notice on this one, we don't have all the terms. We have an x squared and we have a number, but we're missing an x term. So what we have to do is we have to say, okay, well, this is really going to be a negative x squared plus 0x and then minus 1, and that's going to be divided by x plus 1. And so if we write that out, we have x plus 1 into a negative x squared plus 0x minus 1. Now, what do we have to take x times to get the negative x squared? Well, we have to take it times a negative x. So x times negative x is negative x squared. And 1 times negative x is minus x. And again, we're going to subtract that whole thing. So I put the whole thing in parentheses and the negative out front. So negative x squared plus x squared is 0. 0 plus x is x. Bring down our minus 1. Well, that goes in there one time, and we get x plus 1. Again, we're going to subtract that off. So x minus x is 0. A minus 1 is a minus 2. And so this time we have a remainder. And so we're going to put it up here and say it's going to be minus 2 over our divisor, which was x plus 1.
Wait,
So
why is it plus 1 up there on the top if it's x plus 1 and x minus 1? Wouldn't it be on minus 1? Like
well,
like
well,
that.
you're taking that 1 times x to get the plus x because we need to have a plus x. And then when you take 1 times 1, you get a 1. So this comes down from here. So that's why we have a minus. So you're not going to always get what you need. So this case, when we took a plus 1 times this, we got x minus 5. And then when we subtracted, then it was 0. But this time when we take this times a plus 1, we get x plus 1. And so then when we subtract, it's a minus 1, which is minus 2. So you just have to be, again, just look at the first term here and the first term here. What do we have to take this x times to get x? Well, you take it times a plus 1. If we'd taken that times a minus 1, that would have been a minus x, and then it would have been x minus a minus x, so that would have been 2x. And that's, we don't want any x's left when we're done. So that's why it's the plus 1, and we get the x plus 1 down here. Does that make sense?
Yeah, thank you.
Mm-hmm. And so then our answer is going to be a negative x plus 1 minus the 2 over x plus 1. Okay, and so then that is going to be our answer to this one in the full form of our quotient plus a remainder. And when you get these, sometimes you're going to have positives down here, sometimes your negatives. If you have a negative, I just put the negative in between and then put a whatever the opposite of it is up here. So that way it really is just a minus 2 over x plus 1. All right, so let's look at this one. All right, so first let's make sure we have all the terms. We have x to the third, 2, 1, none, and x minus 2. So this one we can just divide as it is. So x minus 2 into x cubed minus 3x squared plus 5x minus 6. And so now we just go ahead and do that. So what do we have to take x times to get x cubed? Well, we have to take that times x squared. And so that times that gives us x cubed. Minus 2 times x squared is a minus 2x squared. And now we subtract, so those go away. We have a minus 3x squared plus 2x squared, so it's going to be a minus x squared. We bring down our 5x. So x times what gives us a negative x squared? Well, it's going to be times a negative x. So that gives us a negative x squared, and then we have a negative x times the negative 2, so it's going to be plus 2x. Now we subtract that off, so those go away. We have a 5 minus 2, so that's going to give us 3x. Now we bring down a minus 6. And to get from x to get to 3x, we have to multiply by a positive 3. And so that's going to give us 3x and then minus 6. Subtract that, that's 0. Subtract that, that's 0. So this one has no remainder. And so our answer is just x squared minus x plus 3. All right, so any questions on that one? All right, so the next one is a little bit different because now we don't just have a plain old x out in front. We have this x squared term. And we also notice we're missing a term here. So what we need to do is, first off, let's rewrite this into 9x to the fourth minus 6x to the third plus 9x squared plus 0x, because we're missing that x, plus 10. And that's divided by, now we have 3x squared. Now we're missing this x here too, so plus 0x and then plus 2. So we have to fill in the missing spots on not only the dividend, but also the divisor. And now what we can do is we can divide the bigger one by the smaller one. So we put our divisor out front, so that's 3x squared plus 0x plus 2 into, and now we have 9x to the fourth minus 6x to the third plus 9x squared plus 0x and then plus 10. All right, so what do we have to take 3x squared by to get 9x to the fourth? Well, we have to take 3 times 3 to get 9, and x squared times x squared to get x to the fourth. So now we multiply all 3 terms here by the 3x squared, so that gives us 9x to the fourth plus 0x to the third, and then plus 6x squared. And then we have that. Now we can subtract off everything there. So 9 minus 9 is 0. Minus 6 minus 0 is just going to be a minus 6x to the third. 9 minus 6 is going to be 3x squared. And now we can bring down our 0x. Now, what do we take 3x squared by to get a negative 6x cubed? Well, we have to multiply 3 times a minus 2 to get the minus 6. And we have to multiply x squared by x to get the x cubed. So that gives us a minus 6x to the third plus 0x squared. And then a negative 2x times 2 is going to be minus 4x. And again, we're going to subtract off everything here. So it's going to be a minus 6 plus 6, so that's 0. Here we have a minus 3 and then 0, so that's a minus 3x squared. 0 minus a minus 4, so it's going to be plus 4x. And now we bring down our last term here, which is plus 10. And what do we have to multiply 3x squared by to get a negative 3x squared? Well, here, this time we have to multiply by a negative 1 because we need to have a negative 3. So that gives us a negative 3x squared. And then we still get 0x. And then we have minus 2. All right, so we subtract that off. So minus 3 plus 3 is 0. 4 minus 0 is still 4x. 10 minus a minus 2 is going to be plus 2. So 10 plus 2 is 12. And so now what we do, we take that whole thing, 4x plus 12, all over our divisor. And when we write the divisor back out again, we don't have to include everything. We can just have the 3x squared plus 2 because that's our original divisor, and that would be fine. And so our answer then is 3x squared minus 2x minus 1 plus, and we have 4x plus, where did 1 go for the 12? Then 12 all over our 3x squared plus 2. And so that then is going to be our solution. And again, nothing changed as far as we still divide the same way. Now this time we just had an x squared term, an x, and then a number, and not just an x and a number. So it's just one extra step, you have x squared there instead. And you could have any number of things. You could have like an x to the third here and still divide it into there. But usually when we're wanting to have factors for a lot of stuff, we're going to just divide by some x plus or minus some k value. So that's what it's going to end up being most of the time. All right. So that's long division. Then we also have something called synthetic division. And this is even easier because we don't even have to worry about the variables. We have to still worry about placeholders. So if there's something missing, we have to have it. But now we're just going to look at numbers only, look at their coefficients of the variable. And so the divisor is going to be in the form x minus k. So that's a key thing you have to remember. It's going to be x minus k. So if you have something like x plus 2, what we have to think of is that's equal to x minus a minus 2. So the minus 2 is what k is equal to. So we have to kind of sometimes convert a plus into the minus a minus. So we remember that a negative 2 is what we're really dividing by. And then the probably easiest way to show you how to do this is just to do it and kind of go through it. So we have a 3, a 2, a 1, a 0, so we have all the terms here. This is really going to be x minus a minus 3. And so minus 3 is what our k is. And so what we do is we put our k out front, so minus 3. Then we kind of do a inverted division sign. Now we write all the coefficients of our dividend here. So that'll be a 3 minus 2, 1, minus 4. And now what do? Well, our first term, we just bring an arrow down and say that goes here. And so that's what we do with the first term. Now it kind of goes as far as what we do is we take whatever is here times whatever is here. So negative 3 times 3 is negative 9. And then we put that here. And so we have that. Now what we do is we just take a minus 2 minus 9, and that gives us a minus 11. Then what do? Well, now we go back to taking this negative 11 times a negative 3, so it's positive 33, and we put it here. And so basically, we are taking this number times this, then that number times that, and we just move it and put it into the next position over. So now we add those two together, we get 34. And then we multiply negative 3 times that, and so that's going to be a negative, and that's going to be a 12, that's going to be 9,102. And so we've brought that up, and so now we add those two together, and so that's a negative 106. And so what we have is, initially we had an x cubed, an x squared, x, and the 1. And we divide by one of these, we know that our next term that we come out with is going to be one lower. So it's not going to be an x cubed anymore, it's going to be an x squared. And so what happens is now we have 3x squared minus 11x plus 34. And then this, the last term, is our remainder. And so that's going to be minus 106 over, and then we have x plus 3. Oops, not 6, x plus 3. And so that would be our answer. And because we don't have a 0 here, that's not a factor. So if we're eventually saying do synthetic division to find factors, with this not being 0 for the remainder, then that's not going to be a factor. So our answer is just what this is here. We just have that. Okay. So again, with this one, we just are really just having to make sure we have all the right terms, find all the right terms. We have 3, 2, 1, 0. Then this part here is going to be the same thing. So we have to think of x minus a minus 1 because we need this to be k, x minus k. So k is a minus 1. So we have a minus 1 out front here. And then we just write our coefficients. 6 minus 10 minus 7 and minus 15. And we bring down our first term. So now we take 1 times that first term, so that's going to give us a negative 6, put it there. Now we add these two together, we get negative 16. Now we multiply here, and we get a positive 16. So then we take 16 minus that, and we get 9. Now, negative 1 times 9 is going to give us a negative 9. And then negative 9 plus the negative 15 is going to be negative 24. And so this is our remainder again. And so what we end up with is 6. Now it's going to be 1 less, so it's going to be x squared minus 16x plus 9, and then minus 24 over our divisor of x plus 1. And that then is our quotient plus the remainder for this division using synthetic division. Okay. So this is a little easier than this stuff because here we had to keep track of all of our x's, x squareds, x cubes, x to the fourth, or whatever. And this one, all we have to worry about is the coefficients, and then we just kind of work our way through and multiply and then basically add is all we have to do. All right, so let's do another one. Now, remember, when we do this, it has to be in the form of x minus k. Well, guess what? We don't have x minus k here. So what we need to do is we need to rewrite this. So that's going to be 9x to the third minus 9x squared plus 18x plus 5. So 3, 2, 1, 0, all over 3x minus 1. Well, what do we have to multiply the denominator by to get this to be a 1 here? Well, if we multiply the denominator by 1/3, 1/3 times that's going to give us x, and then we'll have 1/3 times that's going to give us a negative 1/3. And whatever we multiply the denominator by, we have to multiply the numerator by. And so we're going to have to take 1/3 times everything here. So if we multiply the numerator times 1/3, that's going to give us 3x to the third minus 3x squared. And then plus 18 divided by 3 is going to be 6x. And then plus 5 over 3 all over, and now we have x minus 1/3. And now we're in a position we can actually do the synthetic division because we have some x minus k. So guess what? Our k is 1/3. And so now we do our synthetic division. Now we just write those numbers here in. So we have 3, negative 3, 6, and 5/3. Again, we bring down our first one, which is 3. 1/3 times 3 is just 1. Now we have minus 3 plus 1 is going to be a 2, and it's going to be negative. Now 1/3 times that's going to give us a negative 2/3. Well, we can't just add those. We have to get a common denominator, so we have to multiply this by 3 over 3. So that's going to be 18 minus 2, so that's going to give us 16 over 3. Now we multiply 1/3 times that, so that's going to give us a 16 over 9. Now again, we're going to have to add those together, so we have to get a common denominator, so multiply that by 3 over 3. So now we have 15 over 9 plus 16 over 9, so that's going to be 31 over 9. All right, so now we started with x cubed, so now we know this is going to be x squared, so it's going to give us 3x squared minus 2x plus 16/3 plus 31 over 9, and then we have our thing is x minus 1/3. Okay, so that would be one solution. Now, if they want us to have our original divisor here instead of this new divisor that we came up with, if they want us to put it back into here, then what we need to do is we need to go ahead and take out and multiply by one of the 3's here, because this is 3 times 3. And if we multiply one of those throughout here, that will get rid of the fraction here, and then it'll make it a 3. So that gives us 3x squared minus 2x plus 16/3, then plus 31 over. Now if we multiply one of these 3's, all we're left with is that one. And then 3 times that's 3x, 3 times that's going to be minus 1. And so then we have that, original divisor in the denominator, and our fraction is then 31/3. Okay, so then that would be the final answer here. Okay. Now, if you had this one like on a test or something like that, and you got to that point and you had that correct, then I would probably count it. But really, technically, they usually want you to put it back into that original divisor, and so then if it's easy to do, then you can just do that like we just did there. So, any questions on that one? All right, let's do another one. And again, I think most of the time we're going to run into ones where we have, not something like x minus k, and so you actually have to do some extra work here. And so that's what I'm going to do. And so we have 4x to the fourth minus 2x to the third. Now we're missing an x squared, so plus 0x squared, then minus 4x plus 2 all over 2x minus 1. And so what am I going to have to multiply the denominator by to get this to be an x minus k? Well, I'm going to have to multiply by 1/2. So I'm going to also have to multiply the numerator by 1/2. So if I take 1/2 times everything up here, then I take 4 divided by 2 is going to be 2x to the fourth minus 2 divided by 2 is 1x to the third plus 0x squared, then minus 2x, and then plus 1 all over x minus 1/2. Okay. So now I've got the new problem to work, and so my k is 1/2, so I'll have 1/2, and then I'll have a 2, -1, 0, -2, 1, and I bring down first my 2. So 1/2 times 2 is 1, minus 1 plus 1 is 0. Half times 0 is 0. 0 plus 0 is 0. Half times 0 is 0. And then minus 2 and that is minus 2. Half of that is going to be a minus 1. And when we add those, we get 0. So this time we get a remainder is 0, which is good because that means that this is actually a factor of this original equation. So, or this, you could say this is a factor of this equation here, or this is a factor of this equation, depending on how you want to look at it. And so our final answer then is going to be 2x cubed, because we just do one down below, so that's 2x cubed. Well, that's the x squareds, that's the x's, and then minus 2, and then that is our answer because we don't have a remainder. Those are missing, and so it's just 2x cubed minus 2 is actually our final answer there. Okay. So sometimes it works out nicely. Sometimes, you have a lot more fractions to work with along the way, especially if you have to do something like this one where you have to multiply by 1/2, or the one before where we had multiply by 1/3. All right, let's do another one. All right, so this one, we're back to just x minus k, so we don't have to worry about that. But this time, we're missing a term here, and we're missing a term here. So x to the fourth plus 0x to the third minus 3x squared plus 0x plus 1, all divided by x minus 1. All right. So we're dividing by 1, and so we'll have 1 out here. And we have a 1, a 0, a -3, a 0, and a 1. So we'll bring down that 1. We have that. All right, so 1 times 1 is 1. So we put a 1 here. 0 plus 1 is 1. 1 times 1 again is 1. Now we have a minus 3 plus 1, so it's going to be a minus 2. 1 times a minus 2 is going to be a minus 2. Add those together, get minus 2. Multiply 1 times minus 2, we get minus 2. Now minus 2 plus 1 is minus 1. And so this is our remainder. And so now we just have, going from x to the fourth, the first one's going to be x cubed. So we have x cubed plus x squared minus 2x minus 2 minus 1 over x minus 1, which is our remainder part. And then that should be our answer when we take this trinomial divided by this binomial. All right, so any questions up to this point? Again, like I said, this should be easy stuff. You've probably done it before in classes, and so it shouldn't be anything difficult. And it's a lot of multiply, then add, multiply, add, and then you get done, and then you just have to rewrite it into a format when you put the variables back in for synthetic division. All right, so the next one is use synthetic division to see if the first expression is a factor of the second. If so, show the factorization. So basically what they want us to do is take that number, divide it into this number using synthetic division, and see if it's a factor. So if we get a remainder of 0 on the end. If so, write the two factors. So here we have x minus k, so our k is 2. And then we have a 4, a minus 3, a minus 8, and a 4. 3, 2, 1, 0. Okay, so we're good there. So now we bring down the 4. 2 times 4 is 8. 8 plus the negative 3 is going to give us a 5. Now 2 times 5 is 10. 10 minus 8 is 2. 2 times 2 is 4. 4 plus 4 is 8. Well, in that case, that's not a factor because there's a remainder. And so we can say, so not a factor. Okay. And so we don't have to worry about writing out any factors. So if we get a 0 here, then it would be a factor. But because we didn't get 0, it's not a factor. And so we don't have to worry about it. And this is going to come into play, especially in the next section where we're looking for rational zeros and things like that. We'll start dividing things. And if you get it to be a factor, then we found a rational 0. All right. What about this one? Well, here we have just another expression. So the x, or the k rather, is a 1/2. We have 4, 3, 2 we're missing, so there's going to be a 0. X squared is gone, and then x, and then 1. So we've got a 2, negative 1, 0, a 2, and a negative 1. Okay. So if we go ahead and do like we've been doing, we're going to bring down the 2, and when we do that, we have 2. So half of 2 is 1. 1 minus 1 is 0. Well, half times 0 is 0. 0 plus 0 is 0. Half times 0 is 0. 2 plus 0 is 2. Now we have a half times 2, so we actually have to do something. That's a 1. 1 minus 1 is 0. Well, guess what? That has no remainder. And so this is, so we can say no remainder. Therefore, it is a factor. And so what we have is then if we write it out, we get x minus 1/2 times, now this is going to be the x cubed, and then that's x squared, x, and that's just a number. So that's going to be x cubed, excuse me, plus 2. And, excuse me, oh, that's supposed to be 2x cubed, sorry. And so that's going to be our factorization. So x minus 1/2, which is the factor we divided out, and it says it is a factor. And then our remainder, which or what we get out of it, is 2x cubed plus 2. And so that then is the factorization, doing the division of x minus 1/2 into that polynomial. Okay. And that's another thing. All we're going to do is just keep dividing out until you find one that works and gives us a 0. So when we're looking for the real zeros here in a little while, like tomorrow, we're just going to have to divide out a lot of things until we find the one that actually has a remainder of 0. Once we find that, then we have a factor that actually is going to work. All right, so this one we're looking at, says use the graph of the third degree polynomial and one of the factors which they give us. So, this one says that's a factor. This one over here says that one's a factor. And to write the factored form of the polynomial suggested by the graph. And so basically what we're going to do is we're going to look at where we get an intercept and go from there. So here that says x equals a minus 1. Okay. Well, as that's going to be our intercept, but what would the factor be? Well, the factor would be x plus 1. Okay. And so because that is going to be the factor based on this, what they want us to do is write it out in a factored form. So we're going to have x plus 1 times x squared minus x plus 3, and that's going to be the factored form of the polynomial suggested by the graph. And if we multiplied this back out and then type that into our calculator, we should get a graph that looks something like this. Okay. And so all we're doing was just finding the intercept, and in this case, the x equals the -1, converting it back to the zero product rule. How do we get to that? Well, we set that equal to 0, so we take it back over here, and that gives us x plus 1. So that's the factor. They give us the other one, and so we're done. Same thing works on this one, and we could have it any direction, but this is how the graph is. And so what is that point? Well, that's going to be x equals a -3, and so our factor is going to be x plus 3. And so if we write that out, what we're going to get is x plus 3 times x squared plus 2x plus 2. And again, this isn't really hard. This is just to see, can you get those intercepts off the graph? And then what do you do with them? Well, what do you do with them? You usually put them back into the form like this, because to get to the intercept there, basically you set that equal to 0 and solve for x. And so if you go the other way and get that set equal to 0, that means you have to add 3 to the other side, and we get our x plus 3. All right, so applications are really all that's left here. And so we'll do, I think, 4 applications, and all it really entails is, can you do synthetic division? And so what we have is we have a length of x plus 5, we have an area that they give us, and they want us to find the width. And remember, area of a rectangle is just length times width. So if we take our area and divide it by the length, we're going to get our width. And so we're just going to use synthetic division. You could use long division if you wanted to, but synthetic division is going to be quicker. And so remember, this is going to be x minus a minus 5. So we have a minus 5 going into, now that has all the terms. So we have a 2, we have a 9, and we have a -5. So we bring that down. And so minus 5 times that's going to give us a minus 10. That gives us a -1. Minus 5 times a -1 is going to be plus 5. When you add that together, we get 0. And so this says we get 2x minus 1, and that is going to be our width. And so that's all we have to do, is we just had to divide those out, and we get our width out of there, because we took area divided by length. This is our area, this is our length, and we get out. Remember, it's 1 less than what we had here, so that's the x's, that's the numbers, and that's our remainder. Okay. All right, so this one is a little different. We have length and we have an area, and we want to find the width, but this time we have a huge, polynomial. Now, as far as really would that make sense for a rectangle? Not really, but we're not questioning it. We're just kind of writing what we have. So this one, we don't have x minus k. So what we have to do is we have to write 6x to the 4th minus 8x to the 3rd plus 9x squared minus 9x minus 4 all over 3x minus 4. And so what do we have to multiply this by to get the x here? Well, we have to multiply by 1 over 3. And whatever we do in the denominator, we have to do in the numerator. So going across the top, that gives us 6 divided by 3 is 2x to the 4th. And then minus 8 divided by 3, x cubed. And 9 divided by 3 is 3, so plus 3x squared minus 3x minus 4 over 3 all over, and then we just have our x minus 4/3. Okay. So it's, that part probably is the hardest steps, is to get it all into the format we need it. And now we have x minus k. So our k is 4/3. We're dividing into, now we've got a 2, a minus 8/3, a 3, a minus 3, and a minus 4/3. And because they say this is a length and we need to find the width, we better get a remainder of 0 here. So let's say we bring down that 2. So 4/3 times 2, so that's going to be an 8/3. Well, when you add those together, you get 0. Multiply those, you get 0. Now if we add those together, we get 3. Now 3 times 4/3, that's going to give us a 4. 4 minus 3 is 1. 1 times that's going to give us 4/3. Add those together, we get 0. So we're good because we have a remainder of 0, which is what we had better have to get a width, because we need to have a width. Now, so that's going to give us a 2, and we started with a 4, so now we'll have x to the third. No x squared, and we have a plus 3x plus 1, and that is going to be our width. Okay. And again, all we had to do was just do the synthetic division, and we get our value for the width. The trickiest part on this whole thing was this initial part, getting it from the 3x minus 4 into the x minus k format, where k is the 4/3. Okay. All right, so let's do one now. The next one's going to be a little bit more labor intensive because we're going to have volume. And so they're going to give us a volume of a box, and that's the 18x cubed minus 21x squared minus 40x plus 48. And then they say, okay, well, we give you that, but we also give you a length and a width, and we have to find the height. So what we're going to have to do is we're going to have to do one division for this one division with this one, and when we get done, then we're going to have a height, because what we have to do is take volume divided by length and width, and that's going to give us a height. So we have to do 2 divisions. We can't do it all at once. We have to do 2 at a time, or 2 individual ones. And so they give us things where we don't have a nice x minus k. We have a 3x. So we have to do all that 1/3 stuff again. So let's write it out. 18x to the third minus 21x squared minus 40x plus 48 all over, and we have 3x minus 4. Now, the nice thing about these application problems are we know that when we get done dividing each time, we should get a remainder of 0. And so it's not going to be, that means it can't be too hard as far as the problem goes. So that gives us a 1/3 and 1/3, because when we take 1/3 times that, that gives us a 1, which is what we need. Now we simplify. 18 divided by 3 is going to give us 6x to the third minus 21 divided by 3 is 7x squared. Then minus, well, 40 divided by 3 is 40 divided by 3x. And then plus 48 divided by 3 is going to be 1/6. Okay. Now that's all over x minus 4/3. Okay. So we're going to have 4/3, and now we have our 6, our minus 7, our minus 40/3, and then our 16. Now we bring down our 6, and that's 6. Now 6 times that, well, 3 will go into 6 twice, and we have 2 times 4, so that's 8. Now we have 8 minus 7, so that's going to give us a 1. 1 times 4/3 is 4/3. Now we have a minus 40 plus 4. They already have the same denominator, so we don't have to worry about that. So that's going to give us a minus 36/3. And if we needed to, we could also reduce that at this point, and so that would be equal to a minus 12. So, you know, that's reduced because I can see 3 goes into 36. Now 4/3 times 12, well, 3 will go into 12 4 times, and that's going to be a minus 4 times 4, so that's going to be a minus 16. 16 minus 16 is 0. We have our remainder of 0 that we wanted, and so this is going to be 6x squared plus x, and then we just have minus 12 because we had reduced that to negative 12. All right. And now that was, say we did this one, we divided uh, by the, I don't care, length. So now we have to divide this one by the width. So now we're going to divide that by our width. So that's 3x minus 4. And so we're going to have to do the same thing here. So we're going to have to multiply by 1 over 3 and 1 over 3. So 6 divided by 3 is 2x squared, and then we have plus 1/3 x, and then we have minus 4 all over x minus 4 over 3. Okay. So now we're going to go up here, and so we'll have 4 over 3 into, now we have a 2, a 1/3, and a minus 4. And again, when we get done here, we're going to end up with a 0 here, or we've done something wrong. So we have 2, so 4/3 times 2 is going to be 8/3. Whoops, didn't work right. All right, so 8/3. So 8/3 plus 1/3 is 9/3. Well, that's 3. And 3 times that's going to give us a 4. 4 minus 4 is 0. So we do get what we need of a 0 here. And so that's good. We have a 0 remainder. And so here we started with x squared. So this is going to be 2x plus 3 is equal to the leftover thing, which is our height. Okay. So we had to do 2 divisions, and we had to do, the steps in between to get it so it was x minus k. And then when we got done, our final answer was our actual height.
If the length and the width were two different numbers, how do you know which one to do first?
It doesn't matter. It's what happens is, you could have 12 is going to be 2 times 2 times 3. So no matter which one you divide by first, it's still a factor. And so because it's a factor, it doesn't matter which one. If they would have said, you had a 2x plus 3 for a height, and you had the 3x minus 4 for a width, and you were looking for the length, you could divide by the 2x plus 3 first, or the 3x minus 4, and then do the other one second, and then you're still going to end up with a 3x minus 4 for your length. Does that make
Gotcha.
sense?
Okay.
Okay.
Yeah, that makes sense.
Yeah. Now if for some reason, the only this wouldn't work if we were doing things that didn't divide out evenly. So if we got something besides a nice remainder, and it wasn't doing a box or a volume or something like that, and we were just dividing, then it's going to just come out nasty one way or the other. So it just doesn't matter which way you go when you're doing these nice problems like that, because it's going to come out nicely to get a remainder of 0, and then you just have to do the next one. So it's just because each one is a factor, we can do it in any order. All right, so the last one we're going to do today is going to be the volume of a cylinder. All right, so what we have is, we know the volume of the cylinder is pi times 4x to the third plus 12x squared minus 15x minus 50. They give us the radius, so that's nice. And they also tell us what is our volume equation, so we don't have to worry about that. So what basically is left over? Well, what we're looking for is the height. They don't tell us that, but that's what we're looking for, is the height, because they tell us the radius, they tell us the volume. We know pi, so what is h? That's the whole question. And so what we're going to do is, if we look at this, it's going to be volume equals pi r squared h. And so we're going to divide by pi r squared. And so then that will give us h. And so when we take our volume and divide it by pi, basically those pi's are going to cancel. So we're basically done with the pi once we've done that division. So now all we have to do is we have to take this polynomial, divide it by 2x plus 5 twice, and that will give us our h. And so it's going to be just like the last one, except this time we have a radius and we have to divide it twice into that. So if we start off here, we see that we have 2x instead of an x. So we're going to have to do our normal multiply by some factor. So if we do that, so what we're going to have to do is we're going to have to multiply it by a half over a half. And so 4 divided by 2 is going to give us 2x to the third plus 12 divided by 2 is 6x squared minus 15 over 2x and then minus 25 divided by x plus 5 halves. And so remember, that's going to be minus and minus 5 halves. So we're dividing by the negative 5 halves. All right, so let's write it down here. And so that was going to be a 2, a 6, minus 15 over 2, and a minus 25. And again, when we get down to this point, we should have a 0. Okay. So bring down our 2, minus 5 halves times the 2. The 2's cancel, and we have a minus 5. 6 minus 5 is 1. Minus 5 halves times 1 is going to be a minus 5 halves. Now we've got the same denominator, so we have 15 plus 5 is going to be 20. It's a negative. Negative 20 divided by 2 is going to be a negative 10. And so now 2 goes into 10, 5. 5 times 5 is 25. It's going to be a positive. And so when we add those, we get 0. So that's what we were expecting. That's what we got. And this is an x squared x and then the number. So what we have over here now is 2x squared plus x minus 10. And now we have to divide by that radius again, 2x plus 5. So again, we're going to have to multiply by 1/2 over 1/2. And so that's going to give us x squared plus 1/2 x minus 5 over x plus 5 halves. And again, that's going to be minus a minus 5 halves. Okay. So minus 5 halves into this is going to give us, now we'll have 1, 1/2 minus 5. And again, when we get done, this had better be 0. So that's a minus 5 halves. Oh, whoops, I'm already writing the wrong number down, so we'll never get to 0 there. That's a 1. Now that times that is going to be a minus 5 halves here. Now the same denominator, so minus 5 plus 1 is going to be a minus 4 divided by 2, so that's going to be a minus 2. So minus 2 times that's going to be plus, and 2's cancel, we're left with 5. 5 minus 5 is 0. And so this then is going to be just a x minus 2, and that's going to be our height. Okay. And so that's the kind of problems you're going to see in 3.5. And so hopefully that will help you. And again, like I said, this is probably the easiest section we'll cover all semester as far as I can think anyway. So any questions before we go? All right, well, have a good day.